In this video, we're going to explore how to name and write formulas for acid salts. So first of all, what is an acid salt? It's an ionic compound that's formed from the incomplete neutralization of acids. So let's see what that means with some examples. So suppose you had a polyatomic ion. If you were to combine that with some H+, this is supposed to be an arrow here, you would get an acid. So you would get H2SO4. And let's put AQ there because that's usually what we write down for acids. Now let's say you had a polyatomic ion and you combine it with a metal. You would then get a salt, which is just the ionic compound. And so here we'd have magnesium sulfate, for example. That's the ionic compound. But let's say now you have a polyatomic ion and you combine it with both H plus and the metal. Then you would have an acid salt. So for example, this is an acid, this is a salt. So I'm going to take SO4, and if I combine it with the metal ion and the H plus, now I have an acid salt. Here we have a polyatomic ion combined with a metal ion and H+, and that's an acid salt. So if you know the difference between an acid and a salt, or what they are, then you know what an acid salt is. It's a combination of the two, essentially. So when you're naming these, what you do is you want to name the metal first. You'll use the Greek prefix to state how many hydrogens you have, except for mono. You wouldn't put mono if it's only one hydrogen. And then you name the negative ion. You name the polyatomic ion that's there. So, for example, here I have NaHSO4. So I have sodium, and then I have, you'll notice that we have one hydrogen. So as we said, we have mono, but we don't put mono, so hydrogen. And then this is sulfate. SO4 is sulfate, so then I can put sulfate. Now, over here, I have my metal is potassium. I have two hydrogens, so this is dihydrogen. And then this is not phosphate, but it's phosphite. And you can probably try naming this one over here. This would be the same idea, but it would be potassium, dihydrogen, phosphate instead of phosphite. Let's go ahead and take a look at how to write formulas for these instead. So if you had the name, you would first write the metal ion on the left side, and then you'd write the anion on the right. The anion is basically your polyatomic ion with the correct number of H's attached to it. But you have to build it. So if you have hydrogen phosphate, you're going to put HPO4. And when you have a hydrogen, you increase the charge. So when I say increase, I mean you go more positive. You become more positive by +1. So the charge of this would be, it goes from 3 minus to 2 minus. And if we had dihydrogen phosphate, we'd have H2PO4. And then since we have two hydrogens, it would become 1 minus, or -1. And so that would be the charge of that. So you have to figure out what the charge of your polyatomic ion is when you have the hydrogens there. Since every hydrogen is worth +1, you're just going to make it +1 more positive every single time you have a hydrogen there. Okay. So for example, over here we have sodium hydrogen carbonate. So first I'm going to put, oh, don't forget, you do have to crisscross after. That's important. And then reduce as well if needed. So sodium is Na plus from our periodic table, Na plus 1. And then hydrogen carbonate. So that's HCO3, because carbonate is CO3, 2 minus or -2. But when I add an H, now it should be -1, because it becomes positive, a bit more positive. Then I can do the crisscross, and I get NaHCO3. NaHCO3. You can sometimes also call this sodium bicarbonate, so aka sodium bicarbonate. And that's to distinguish between di, which is 2, and bi or di. Di is 2, and then bicarbonate indicates the HCO3 polyatomic ion. It's another naming system that you can use as well. You might also recognize this as being baking soda. So this is also baking soda, sodium bicarbonate. Let's go ahead and try another one. So let's do the sodium dihydrogen phosphate. So sodium is Na plus 1. Dihydrogen phosphate, we already figured it out up here. So I'm just going to go and plug that in here. H2PO4, and treat it like a polyatomic ion. Minus 1 there. And then just crisscross, and you get Na2. Sorry, not Na2. We don't have a 2 there. It's just NaH2PO4, because it was 1 and 1 on both sides there. And you don't have to put the bracket when you have the 1 and the 1 there. Okay, let's try this one here. Calcium dihydrogen phosphate. So calcium is plus 2. Dihydrogen phosphate is H2PO4 with a minus 1 there. We can crisscross it, and we get CaH2PO4 with a 2 there. And that's calcium dihydrogen phosphate. And then now we'll try for potassium dihydrogen phosphate. So we have K plus 1. We have H2PO4. And we said that was negative 1. And then we can crisscross. And then we know that since it's 1 and 1, we can simply write K H2PO4. So you can try these out to make sure you can write the formulas from the names. The only tricky part really is coming up with the polyatomic ion when you have an extra hydrogen added there, with the proper prefix, of course, and then remembering to reduce as needed, because it does count as a polyatomic ion. And if we go take a look at the notes here, on the slide deck, you do have some videos that go over acid salts in some more detail. So you can watch those videos to get more practice problems done there. And the answer keys are included within those videos. And then same thing over here, there's some videos that go over writing formulas for acid salts from the name. So you can watch these videos again to get a different perspective and a few more practice problems to try that out. In our next video, we're going to go and name compounds with hydrogen as either the first element or the second element to finish off our naming.